Far beyond the familiar planets and the warming influence of the Sun, a remarkable spacecraft is still sending faint messages back to Earth. Voyager 1 was never expected to survive this long. Built during the 1970s, decades before modern computers and the Internet transformed technology, it was designed for a relatively short mission. Its purpose was to fly past Jupiter and Saturn, capture images, collect scientific measurements, and eventually fall silent. Instead, it kept traveling. Year after year, Voyager 1 continued its journey into the unknown. It crossed the outer reaches of the solar system and became the first human-made object to enter interstellar space. From a region no spacecraft had ever explored before, it began revealing something unexpected. The environment beyond the Sun's influence was not the quiet emptiness scientists had imagined. Instead, it appeared dynamic, turbulent, and filled with hidden activity. This discovery matters because the edge of our solar system is more than just a distant boundary. It forms part of a protective bubble surrounding the planets, helping shield Earth from powerful cosmic radiation traveling through the galaxy. By studying this frontier, Voyager 1 is helping researchers understand not only deep space but also the invisible barrier that contributes to making life on Earth possible. Voyager 1 began its historic journey on September 5, 1977. Its mission focused on exploring the giant planets, and it quickly exceeded expectations. During its encounter with Jupiter in 1979, the spacecraft transmitted stunning images and valuable scientific data that transformed our understanding of the massive world and its moons. The following year, it flew past Saturn, revealing remarkable details about the planet's rings, atmosphere, and magnetic environment. These close encounters did more than produce incredible discoveries. The immense gravity of Jupiter and Saturn accelerated the spacecraft, sending it on a one-way journey toward the edge of the solar system. By the end of the 1980s, Voyager 1 had become the most distant human-made object ever launched, yet it continued transmitting data across billions of kilometers. Everything changed in 2012 when Voyager 1 crossed the Heliopause, the outer boundary where the Sun's solar wind gives way to the material filling interstellar space. Inside this vast bubble lies every planet, moon, asteroid, comet, and every form of life humanity has ever known. Beyond it stretches the space between the stars, shaped not by our Sun but by the wider Milky Way galaxy. Crossing that invisible frontier marked a historic achievement. For the first time, scientists had a functioning spacecraft collecting direct measurements from outside the Sun's protective bubble. Instead of relying only on computer models, they finally had real observations from the interstellar environment itself. Before Voyager's crossing, many scientific models suggested that interstellar space would be extremely thin, cold, and relatively calm. While it was never expected to be completely empty, researchers believed conditions would remain fairly uniform. The spacecraft soon revealed that reality was far more complex. Several years after entering interstellar space, Voyager 1's instruments began detecting a faint but persistent signal within the surrounding plasma. Rather than appearing as a brief burst or temporary disturbance, this subtle emission continued over long periods as the spacecraft traveled farther from the solar system. Its consistency allowed scientists to continuously monitor the properties of interstellar plasma in ways that had never been possible before. Earlier studies depended mainly on occasional disturbances created when powerful solar eruptions reached the edge of the solar system. Those events provided only brief snapshots of conditions beyond the heliopause. Voyager 1 changed that by supplying a continuous stream of measurements, revealing that the space between stars contains changing densities, complex structures, and ongoing turbulence. Instead of an empty and motionless void, interstellar space behaves like an active environment with constantly shifting conditions. The discovery challenged earlier assumptions and suggested that scientists still have much to learn about the region surrounding our solar system. The unusual signal was only one of several surprises waiting beyond the solar system. Even before Voyager 1 officially entered interstellar space, its instruments detected unexpected conditions near the Heliopause, the vast boundary separating the Sun's influence from the surrounding galaxy. Scientists had long expected this region to act as a gradual transition zone where the solar wind slowly weakened while interstellar particles became increasingly dominant. Instead, Voyager observed a far more energetic environment. Measurements revealed intense activity involving charged particles moving at remarkable speeds. These particles interacted, compressed, and generated extremely high temperatures within the boundary region. Although there are no flames in the vacuum of space, the immense energy concentrated there has led some researchers to describe this area as resembling a wall of fire. The term is symbolic, referring to energetic plasma rather than burning gases. This outer boundary serves an important purpose. The heliosphere acts like a giant magnetic shield surrounding our solar system, helping reduce the number of high-energy cosmic rays that penetrate into the inner planetary region. Many of these particles originate from violent events across the Milky Way, including exploding stars and other energetic cosmic phenomena. Voyager's discoveries suggested that this protective shield is far more active and complex than earlier models indicated. Instead of functioning as a simple barrier, it constantly responds to changing conditions in the surrounding galaxy. That realization has major implications because the strength and behavior of this shield influence the radiation environment experienced by Earth and the other planets. The spacecraft also recorded surprising magnetic field behavior. Before the mission reached the Heliopause, many scientists expected the Sun's magnetic field and the galaxy's magnetic field to remain largely separate. Voyager's measurements painted a different picture. The data indicated that magnetic fields from both regions interact more closely than expected. Their lines can shift, reconnect, and exchange energy, creating a constantly changing environment at the solar system's outer edge. Rather than existing as isolated systems, the Sun and the Milky Way appear linked through an ongoing exchange of plasma and magnetic forces. This changed the scientific view of our place in the galaxy. The solar system is not enclosed inside a perfectly sealed bubble. Instead, it travels through interstellar space while continuously interacting with its surroundings. The boundary moves, responds, and evolves as conditions inside and outside the heliosphere change. Perhaps the most remarkable aspect of this discovery is that it nearly came to an abrupt end. In 2023, Voyager 1 suddenly began sending corrupted engineering and scientific data back to Earth. Although the spacecraft's radio transmitter was still operating, the information it carried became unreadable.